close to the end, it's just beginning. Life is getting lighter while the days are getting brighter, yeah. And it's a good, I won't even worry anymore. Took all my cares, still can kick them all out the door.
So this is the third year I've done this, and I know you're not here to see me. If I remember right, we've got a really good giveaway coming up here as soon as we're done with this session, right?
You are correct, sir. We have a Samsung Chromebook that will be given away right after John's presentation. And when I said, you know, participate, as you participate in our IP talks, you get one of our nice shirts. Got IP? Got IP? Yes, from ChipEstimate.com. So participate, we'll get you one of these, okay?
All right, so since
Thanks,
everybody's anxiously awaiting the giveaway, I'm only going to talk about 2 hours. And as soon as I'm done, then we'll do the giveaway. But seriously, it's nice to be back here. I can't believe this is the 50th DAC. Fortunately, I have not been at all 50 of them. And we've been doing a survey and wondering, you know, who here has been at all 50 DACs? And if you do the math, it's pretty tough. If you went to DAC your freshman year in college and have been at all 50 DACs, you're 68 years old, maybe 69. So I don't think there's too many people here that have been at all 50. I've heard rumors that there's some brothers that have been at all 50. But so I'm from Synopsys. I've been with Synopsys for over 20 years. I go back to logic automation days, and I've had many different jobs over the years. I'm going to give you an update on kind of what's new with DesignWare IP. Some of you may be familiar with it, may have used it before. We've amassed quite the portfolio over the years. It actually started with the data path technology. A lot of people don't realize, but in the early days of Synopsys, we started creating multipliers, floating point components, data path components that work very closely with your synthesis tool, with Design Compiler, ICC Compiler. So, when you're trying to get time enclosure, there's certain adder structures that work very well, certain multipliers, and then if you think about floating point in hardware, it's not simple, because you got to make sure the rounding is proper all the way. So there's a whole library, and this has been on the market for a very, very long time. Okay? But what we're going to talk about more today is kind of the bigger blocks, what people think about IP. So of course there's the AMBA on-chip bus, and here we show, AMBA 3, AMBA 2, and any day now, AMBA 4 is going to be added to this. So you'll be able to do ACE, ACE Lite. The traditional stuff, USB, Ethernet, SATA, more recent additions, ARC and the DDR4 and the low power, the embedded memories. So we've really got quite the portfolio of IP. Now, we're lucky at Synopsys because we run the Synopsys Users Group and we get really good feedback from our customers. So this is one we show every year. And at the SNUG, and you can see this is from the Synopsys Global User Survey in 2012, we actually ask, which process node was your last chip on, your current chip on, and your next chip? And you can see, 250 nanometers, that's pretty much dropping off. But if you're doing automotive chips, you may very well be on this type of a process. The certification is pretty gnarly. With our Ethernet, we've had a lot of automotive chips done recently. Whether you realize it or not, Ethernet is slowly taking over your car. It started with in-vehicle infotainment, audio-video bridging specifications, and now it's moving out. It's actually going to go under the hood before too long. But once again, no surprise to us, but surprise to a lot of people, over 60% of the designs are less than or equal to 32 nanometers. And this is important because not all the IP is RTL. The PHYs are physical. And so we have to make sure we can port the IP to the process nodes that you're using. So if you're on, moving to the 16 or 14 FinFET technology, we got to have the IP there ready for you to use it. And we do. So these are two recent announcements where we put together the flow with Global Foundries for 14 nanometer FinFET offering. Not just the IP, but the whole tool flow to make it easier for you to do your chips. And with Samsung, we have actually already done a 14 nanometer FinFET tape out. So we're working, with leading companies, making progress to make sure our IP is ready. And it's really good IP. Now, I don't know if y'all are familiar with the eye diagrams, but this is really good. You can see there's lots of margins. You've got USB 2, you've got PCI Gen 2, and the MIPI D-PHY. And in every one of them, the eyes here, lots of room, lots of margin. So you're going to get real good signal integrity. We tape out all of our PHYs, and here's the memory compilers, USB 3, USB 2, and MIPI PHY. So these are actually test chips that we take through certification to make sure our IP works for you. We are a leader in 28 nanometer. We've ported, USB, PCI Express. I won't read off the whole list, and it's not just the PHYs. There's analog components too. Yeah, I lead the automotive initiative in the IP group at Synopsys, and one thing we have to get reminded of a lot: the real world is analog. In digital world we tend to forget that, but the real world is analog. So when you're mixing the fuel that's going into the engine, these analog sensors that are telling you how much fuel and how much oxygen and things are getting in there, you need to convert that to digital data to get it into the CPU, because yes, there's CPUs running these things, so that all the information can be displayed. And I bought a new car recently. They've taken it a whole nother level. I can push a button and go to 3 different transmission settings. The first one is called economic. It's boring. You step in the gas and a red light comes on and says, warning, you're wasting gas. Like, okay. Second, we don't use that mode very much. Probably should, but don't. Second mode is comfort. Car runs real good. It's got some pretty good zip in it, but it's not real sporty. Third one is sport mode. You get 4 miles a gallon less when you put it in sport mode. It's worth it. It's fun. But anyway, 28 nanometer, over 100 wins with more than 30 tape outs, test chip tape outs at 28 nanometers. So we do work. One of the exciting new things, so I manage Ethernet and lots of other things in Synopsys, and 10 gig was kind of a disappointment in Ethernet. The IEEE specs, and I apologize if any of you were involved on it, were horrible when the standard came out. And it created a lot of proprietary solutions, fragmented the market. For 40 gig and 100 gig and the new 10 gig, the specs are good and solid, and we're seeing a lot of adoption for this. I live in Portland, Oregon. We can now get 10 gigabit Ethernet to our house. You pay dearly for it, but you can get it. Comcast will run the fiber cable to your house. They already have it. It's cable. It's been there forever, right? You can, I think it's $250 a month, and you can get 10 gig Ethernet in your house. So we released the new Enterprise 10 gig PHY. We've had the 10 gig digital for quite a while, actually for over 6-7 years. And this will support both 40 gig and 100 gig. Supports all the base standards, including PCI Express Gen 3. So one PHY, pretty complicated PHY. Also, energy efficient Ethernet. That's really important. I did a paper not too long ago, actually I guess it was over a year ago, on how much energy we waste with Ethernet, and it's incredible. If you watch the Ethernet, IP traffic on your computer, you'll see it's not doing much most of the time. You search the web, something goes out, and it comes back. All governments are mandating this. It's true in America, it's true in Europe, it's true in China. And the amount of energy we save by deploying energy-efficient Ethernet is going to be huge. The new DDR4 memory. So this is the new, both the PHY and controller. Supports 4.3 and low-power DDR2.3. It's faster, lower latency, new low-power features added to it, and it's all done through the DFI 3.1 interface. So we're pretty excited about this. We're getting a lot of customers that are using this. UFS and MIPI UniPro. So UFS, honestly speaking, I think maybe was a little overhyped. It's not going in all of the designs that the standards committee would have had you believe. If it's a Windows design, UFS fits very well into it because of the way the operating system works. If it's an iPhone or an Android phone, they're probably going to stay with eMMC. But there are tablets. Windows tablets are going to UFS. Windows phones are using UFS. And a lot of companies are looking at it. So we've got the controllers and the PHYs for complete MIPI and UFS systems. The new memory and tests. So once again, I've been using automotive today as an example because I bought a new car and I like to talk about it. But if you think about error corrections in memories, this is really important. And if you put it in a critical system, an automotive application, it's really important because when you step on the brakes, you want the car to stop. And these new cars have a lot of sensors and warning systems. I mean, my car has the sideline. When you cross the line, it beeps. I think they call it sleep avoidance. So if you start drifting over in the road, it senses the line on the side of the road and actually makes a noise and wakes you up. So we have, very area efficient memory test and repair, and we targeted at 20 nanometers and below. So for all those critical systems or video systems, consumer systems you don't want glitches in, it all can get built in. Very, very efficient. So what have we been focusing on this year? Well, just kind of summarize. The high-speed SerDes, DDR4 and low-power DDR, HDMI 2.0, MIPI, UFS, Enterprise Ethernet. There's a lot going on there right now. One of the things which has changed in the networking world, so Enterprise Ethernet used to always say, well, that's Cisco, right? I mean, they're the ones that do the big servers, and is this an IP business? Well, there's a company down there called ARM that seems to have decided they want to get into the server business and take some of Intel's money. And so there's a whole bunch of companies doing designs for Enterprise Ethernet right now. And it's going to be an interesting battle. We'll see who wins in a few years. The other exciting thing, because I've talked about the analog IP and the PHYs, USB, the ARC processors, which we've had for a couple years now. But one of the things we're doing with the ARC processors that is really cool is the audio subsystems, or subsystems in general. The first one we did was the audio subsystem. So if you're doing a chip for cell phone, an automotive infotainment system, you can take an ARC-based audio subsystem. It's pre-certified. We've run it with all the different software, and we've put together virtual prototypes, hardware prototypes on HAPS, and of course the RTL and all the software that we've tested it with. So as a designer now, you can take a complete audio system and drop it on your chip, and it of course supports the AMBA interface. So we've been in this business a long time. We are ranked #1 in most of the categories we participate in. We are the #2 interface #2 IP provider, #1 interface IP provider. We're very open. When you license our IP and there's a bug, you can find out about it on the web. You can get notification as soon as anybody hears it. We're always one of the top suppliers. We are a leader. It's growing. We have over 1,700 engineers working on it and 140 support people. Last year when I did this, there were 1,400 engineers. So we've added 300 engineers in a little over a year. And it's a serious business for us, over $300 million in revenue, according to the DataQuest report. So that's the end of my presentation.
Questions?
Now we get to the fun part.
Yeah, any questions? Questions? You got one, okay.
What is the status of your DDR4 IP? Is it something customers started implementing and released?
Yeah, we're providing it to customers right now. So the DDR manager is here. He's in the Synopsys booth today. Drop by and we'll be happy to get you a lot more information on it.
Did you talk about FinFET?
I think that's on 28, actually.
Okay. Any questions on the 14 nanometer, or is it the FinFET 14?
It doesn't say.
Okay. Maybe tell us what you're doing.
I'm going to have to go look that one up.
Okay,
I'm
that's
not
all right.
sure.
That's okay.